everybody, my name is Abubakar Usama and I am the local chapter lead for Medina, Sudan. Today I'm going to give you a walkthrough of what we did in week one. It's going to be a very quick walkthrough. I hope everybody catches up. So we're going to use Google Collaboratory. Google Collaboratory is a tool that basically provides a cloud runtime environment for you. It also allows you to integrate Google Drive, which provides external storage. So basically you have a computer remotely. Find it, you could just Google collab basically, and it should be the first result. Yeah, collab.research.google.com. That's going to be a runtime environment. Um, my internet connection sort of sucks, but make it work. So basically, this is Google Collaboratory. The first thing we're going to do is we're going to create a new notebook. Basically, a notebook is basically a cloud runtime environment. I have to make a login. Hopefully it works. I don't update. Hopefully no one saw the password. Don't hack me, yeah. All right, so yeah, we're gonna create a new environment, and basically Google Collaboratory allows us to execute our code in cells rather than the whole block. Basically, it also helps us organize. We can add comments. It's like a portable runtime environment that's meant for everybody, basically, because you can comment your code, and it's really easy working with someone's notebook. So today we're going to create our own notebook. First we install the necessary libraries, which are face recognition, and then we do pip install I think sklearn. Yeah, so this basically prompts Google. First let me connect to the runtime. Sometimes it doesn't connect, so basically if you want to make sure you're on the right runtime, go to hardware accelerator and pick GPU, because what we're doing basically demands for a GPU. Connecting, hopefully connects. Okay, connected. So basically I'll execute this code cell. While it executes, I'm going to go through the next code cell. But let me just point out that basically here we're installing the necessary libraries to our collaboratory environment. So basically we will have access to these libraries as long as they're basically supported by the pip module. So pip is basically installing everything for us. Pip is one of the libraries that allows us to download stuff, on Python. Basically, if you run it locally, you're going to use it a lot. Even in Google Collaboratory, you'll probably be using it a lot. Next, we do import face recognition, and from sklearn import datasets. Should work, I think. Then yeah, okay, so we're gonna do the imports. If everything goes through, you should end up with a tick mark right here. That indicates that the code went through. So we created two new code blocks. If you can notice, we're executing stuff sequentially. That's one of the bonuses of using Google Collaboratory. Okay, we're gonna do sk.learn okay. We're gonna do datasets dot fetch lfw people. I think this should work. We add the home directory for this one. Home equals before I do this, there's something I forgot to do. So basically, we're gonna do import Google Collab. Import actually from Google. Import collab dot drive. I think drive. We mounted in content. Content dot drive. Let's highlight this thing and add quotation marks. Okay. Now let's see if this runs. Module object not callable. Call dot mount maybe. Okay, let's see. Yeah, okay, there's an indicator that worked. Basically, it's gonna ask us, do we want to give permission to this notebook to basically get access to our drive? And I'm gonna go for yes. It's really a security question, so it's up to you, you know. Ah, I want to play some music though. Anyhow, mm, I will play some music. Okay. I should have a file here. Mm, yep. Hopefully this is better. I'm gonna run this. Basically, this is fetches the data set, and I can't have to cancel this one.
Just to say something real. There's a light on the road, and I think you know. Morning is coming, I have to go.
Data home.
I don't know why, I don't know why. We need to break
Content.
so hard.
Slash
I don't
drive.
know why we break so hard. But if we're strong enough to let it in, we're strong enough to let it go. Oh, 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 oh. Let it all go, let it all go, let it all out. If I look back to the start now, I know.
All right. So basically, here it just confirms that we mounted Google Drive. Right now, I'm accessing my Google Drive through this collaboratory. From here, I'm using the dataset.fetch.lfw people. Basically, fetch.lfw people is a method or a function of datasets. Datasets is what we imported from the sklearn library. So if you're getting the breakdown, basically libraries allow us to utilize, the code within them, the objects, the functions. It's very it's very simple to make a library as well. You could just create a library, call it lib1, for example, and put it in the path. Basically, there's like a path for libraries, and it will import. You could also put it in the same working directory as you're running and do import lib1, and it should import. You could even say from the location of your library import blah blah, and it should import. Now we're gonna run this function. Hopefully it's gonna work. Operation not supported. Hmm. Should work now. See, it's fetching. Okay. So we're gonna assume for safety's sake this line worked, I think. Next we're gonna do from, let me copy this directory because we're gonna need it. Uh, image dir, we're gonna call it image dir, and basically we're gonna store this as a variable. So now we created a string variable. Unlike most languages, you don't need to define the variable type, which is basically string, integer, uh, those data types. But a data type basically describes it. So this is a string data type. If it was a C, just if I passed in a C, that would be a character data type. If I pass in a 1, that's an integer. Pass in 1.0, it becomes a float or a decimal, depending on the language. But in Python, you don't need to define all that. You just define the variable and assign the value you want to assign to it, which is what I did here. Hopefully, you guys are hearing this pretty well. I'm going to keep going. For I in image dir, basically, this is a for loop. Okay, yeah, this is an indicator, download everything. Oof, I executed by accident. For I in image directory. Oh, did I import the OS module? I didn't import the OS module, but let me import it again. Just import it, it's very simple. I run this again, yeah, we can now have access to the OS module. For OS, so basically the OS module is a very important module. It allows us to manipulate our current operating system or our current working environment to access some features. We could traverse a path, traverse a system path. Like right now, I'm going to traverse the directories. We could use it for copying, making files. Is very important. So basically, from os.path, I'm going to import list dir if I'm not forgetting it. Okay. I can't press shift. I keep pressing shift. Image directory. Image dir. Then okay, for I in for x and I. For x and I. Okay. Now we're gonna do phase recognition dot load image file. We're gonna load the image file basically. X goes in here. I'm gonna create something to store, the variable, so we're not doing anything for like nothing, Face, face. Here we're gonna define this is dictionary type basically, so it's organized and basically everything is in order. Basically, you'll learn as we're doing it. So face dictionary, and then we're gonna do counter just to have a counter. We're gonna do face ID, basically list of face IDs, or yeah, list of. Leave it a none. Give it a non type. Encoding list equals an empty list. So for I in image, uh, face ID equals I. And then for X in I, I want you to add X, which is basically, since this function basically converts our image. I forgot to describe this. The for loop. I'll go through it. We defined a dictionary, we created a counter, we created one variable that's a none type. A none type is basically, it's a none, it's just a placeholder. We created a list called an encoding list. A list is basically an unordered list of stuff. You could have A, X, Y, B's, like all separated by commas, and it'd be unique objects, unique parameters of the list. Could have 1, comma 2, 3, 4. So basically, our list would have 1, 2, 3, 4 as elements. Now here we're assigning our face ID to be the file we're traversing, because this library basically the lfw.home. I have to fix that. See, that's why you should open a file class. lfw.home and then lfw.funneled. So this lfw.funneled is basically a list of basically files that each contain images. It's just taking a while to load. I could do this. Well, let's see. So basically, when it opens, it should have files with the names of any names: Abu Bakr, Sarah, Khalid, Yusuf, Joseph. You have a list of those files, and within those files, there'll be pictures of those specific people. So it's very organized, very labeled. Uh, it's not opening for some reason. It's very delayed. I wanted to show you guys how the file looks like, or to save time. I'll just leave it open. This should load in a bit. So basically, for image file, for a file in this image directory, I'm gonna assign it as the face ID, and then I'm gonna do. I'm gonna increment count by 1. Oh yeah, it opened. It even moved our run. So basically, you see this, and then this should have a number of images under this guy's name. For I, so basically for each face ID, count equal count plus 1, increases counter for x, and then do encoding list. No, I'll even put it here. You know, it empties the list every time. So here I'm saying if face ID is not equal to none, I want you to basically make face ID equal to none. Let's see how this goes. Yeah, sometimes the logic escapes me, you know. Okay. So face encoding. I'm just gonna call this FE for now. And let me assign this to face dict I equals face dict should equal coding list. So we're gonna use append here. Hopefully this should work. Just to make sure. I'm sorry if I took too long to process, but let's see. Face dict. Also, I want you to increment the counter. Count. If count and break. So we want to run this like minimalistically. I don't want to run it all because it's going to take time. So basically, if count is equal to blah blah, if it's equal to 15, I want you to break, exit this whole loop. Just print the face dictionary. Let's see how it runs. Let me type it again. Looking in the documentation. Huh. Let's see how it goes. Okay. Rex and I. See what happened here. String X is K. Hmm. Okay, let me try this. Plus I plus slash plus X. Where's this K coming from? Hmm. Wow. Let me try to execute this line one more time. Excellent. Ah, see how this works now. Where did I mess that one up? Here. Ah, encoding. List. have to append the FA. Yep. So we've done it. Basically, this is a program. How long did it take? 26 minutes. All right, so we have some time for me to revise. I was hoping to finish this in 30 minutes just to show you how straightforward it is. But yeah, we ran into some difficulties and we overcame them. So let me go through this again. First, we install the necessary libraries for Google Collaboratory by using the pip install command. We can do pip install face recognition, pip install TensorFlow, Keras, Brosa. There's a lot of libraries we can install, and this is all done through one command, which is pip install. There's a few other things in pip. There's pip upgrade. There's a whole like documentation. Go read about it. Next, we import the necessary libraries, which include libraries we just downloaded. Face recognition is one example of those libraries. We also import from sklearn, basically, which means from the sklearn library import datasets. Just like we could say from face recognition import load image, which is just a function within face recognition. It could be specific, but here we're importing the entire face recognition library. And from here, we're importing datasets as an object specifically from the sklearn library. We also import OS module, which, like I said, is a very important module. It allowed us to do all this manipulation. It's basically at the back end of most of the libraries and applications you use with Python. Next, we do a Google Colab exclusive thing, which is basically do we import the Google lib from the Google library. You import the collaboratory object basically. So we're not getting the entire Google library. We're just getting the collaboratory object. This is a function that's specific to Google Colab, I think, and it allows us to mount our drive. So now we have this is our drive. Crazy amounts of data, almost half of 40 gigabytes filled. So basically, you have a computer that's fairly decent. This is an indicator it worked, and then we do this. From the datasets object we got from sklearn, we use the fetch LFW people, which is a method or a function of datasets. And yeah, it allows us to download the dataset from the internet, which is pretty cool. So here we just download the dataset, and this is the dataset literally. I think it comes in the form of a numpy array. But I chose to just do it ourselves. Who knows? Maybe a dumb decision. Anyway, after we download it to the directory we specified, which is this directory, uh, we create the image directory, which basically stores our samples. Our samples are stored in lfw.funneled. We define a dictionary to basically store our biometrics. So now I think each user, like these are all so much data. So this is an numpy array. Okay, here. I think it should, yeah, see, it should have this guy's name, comma, some other guy's name. So these are all just values. Uh, okay. This was an unnecessary line, but yeah. Anyhow, I'll go through it. Sorry, this is one of my first videos. So then we do the face dictionary. We also initialize a counter at 0. We create a face ID object, which is assigned to none. And then we create an encoding list, which is basically a list. Lists and dictionaries here allow us to basically organize data into a data structure that's global, basically. In every language, there's like a list and a dictionary, which is all could be called a tuple. I'm not sure. Anyhow, for I in os.lister, os.lister is a function of the OS module, which allows us to basically list directories of a specific path and return them as a list. So here we're using the for loop. For loop basically requires an iterable. So an iterable is a sequence or range of objects, not just one object. So it could be 10 objects, and for I in the 10 objects, print I. Or for example, you could have a list from 0 to 10 as just value 0, 1, 2. And then if you say for I in that list, it's going to give you 0, 1, 2, 3. It's going to return elements of the list. Basically, it's a control statement. Here we also define an if function. I'm not sure how useful this line is, but I just defined it. So an if function says if this statement is true, then I want you to execute this statement, which is under, it's under the if statement. Indents here matter, the if is indented within the for loop, and the the function we're going to activate if this statement is true is indented within the for loop. So focus on the indents. I'm not just doing that. If face ID is not equal to none, this is basically not equal. If we do double equal, basically we're saying it's equal to none. We could do greater than or equal to or less than, but here we said not equal to. Then set face ID to none and create the new encoding list, basically. So this executes every time except the first time, and then I want you to set face ID equal to I. Yeah, so basically sets face ID equal to I, and then we say for x in os.lister. So again, we're creating a list of directories, but this time it's a list of directories within this directory. So within this, so basically, you know how it iterates through each directory within this provided directory. Now we're iterating through each of the directories returned by this. So it's like a double iteration. This seems cool. So then we create a new variable that's basically equal to face recognition.load image file, which basically loads an image file and returns it as a numpy array, which is basically a numpy array defines the pixel values of the image. So we can go into detail about that if anyone wants to ask about it. And then we append FE into our encoding list, which is basically this list right here, this list object. After we're done, after it appends all the FE executions, I want you to basically assign I as the key, which is basically the file name. Assign it as the key. And then I want you to assign the list as values. I want you to increment the counter by 1. And if counter is equal to 15, I want you to break. We can print the count. So here are the print statements. I'm not sure if I explained it. Print basically prints the line or anything you want to print, basically. And there is the, how do we input again? Input. Forgot about that. Anyhow, we do F. If X is equal to exec indexed count, index count. Yeah, so basically you print a statement. You also use this, which is basically an F string. Whenever you use this, you can basically add variables just within brackets. Like I could add face tick, print the face tick here. I could do face ID. I could basically print variables, and since they're within the curly braces, and I use an F string, the interpreter knows that I'm talking about an object called count within curly braces, not a string called count within curly. Hopefully we're gonna print this again, just for heck's sake. Okay, I printed 15 exactly, and that's it for today. Hopefully next time I'll remember how to show you guys how to do the input. See you guys around. That was 35 minutes, and it's